Hello and welcome to this presentation on evaluating outcomes. In this presentation, we're going to be looking at what's called expected value, or we might be calling it expected profit. Those will be used interchangeably as we go through this presentation today. We're also going to look at ROI, or return on investment. You'll learn how to calculate that. You're going to look at constructing a decision tree. Also, we're going to talk about variance and standard deviation. Now, hold with me through that one, but don't worry, it's relatively easy, and we'll have some examples to illustrate how to calculate those. And then lastly, we'll talk a little bit about sensitivity analysis. There's a couple things I want you to do. Before we go forward, I want you to take a moment, pause the video, and I want you to get a pencil, some scrap paper, and a basic calculator. One that can do squares and square roots. Pretty much any calculator should be able to do that. Again, don't worry if you have a little phobia about math. We have some very simple examples in here, and we'll go through step by step on how to calculate these items. So let's get started. To illustrate this today and all these topics, we're going to be telling a story. So imagine that you are a manager of an imaging facility in a hospital. CT, MRI, X-ray, ultrasound, all those gizmos. You're in charge of all that and all those people. And the manufacturer rep has come into you and has sold you on the latest, greatest scanner. This thing is going to be the end-all, be-all, cutting-edge technology. And you say, all right, this sounds pretty good. I think I'd like to buy this for my department. So a part of this decision-making process is making sure that you make a wise decision. So you're going to gather some information about the scanner. The first thing you're going to find out is the price. And they tell you it's $1 million, but it's a heck of a deal because this particular scanner is going to be able to generate between $80,000 to $170,000 in profit for you every year. Again, the low end being $80,000 and on the high end, $170,000. Sounds pretty good, right? Well, let's just find out. There's a little bit more information we need to know. All right, so you get a little bit more information, and here's what you find out. You find out that there's a 70% chance that you'll make that $170,000 that the manufacturer's rep told you about, and that there's a 30% chance that you'll make the $80,000. Let's say you surveyed 100 of your peers who bought this scanner, and 70 of them reported back to you. Again, they made $170,000 on this, and then 30 of them reported back $80,000. So that's where you got your numbers from. So what you want to know is, what is your expected value or expected profit? Well, let's make a tree to find out. Not this kind of tree, but it's going to be kind of a stick tree here. All right, let's start off with those numbers. Remember the numbers again? 170,000, that's kind of the top end of what you're going to make. And then 180,000, that's kind of your, I guess, worst case scenario. You're going to make little branches. Again, we're making our little tree here, because these are really our two outcomes that can happen. And then we're going to assign some probabilities to those branches. Uh-oh, subscripts here, don't freak out. You got the P with the subscript equaling 0.70 or 0.07, and then P subscript 2 equaling 0.3. Let's talk about that for a moment. About these probabilities and these subscripts, don't worry about it. If you think about it, the P with the subscript 1, that's our probability 1. That's the 70% chance that you're going to make that $170,000 on it. And the P with the subscript 2 is our other choice, which remember was 30 people out of 100 reported back, they only made the $80,000 on it. So again, think of it like in percentage terms. The 0.7 is equated to 70%, or 70 over 100. But when we write probabilities, we write them as a decimal point out of 1. So knowing that, imagine if you had a 100% chance of something going to happen. 100 out of 100 people reported back to you they made, $180,000 on the scanner, you would have a probability of 1. So now you know a little bit about probabilities. You know that your probabilities are going to range from a 0 or near 0 all the way through a 1, which is 100%. Okay, enough about those probabilities with those funky little subscripts. Hopefully you feel a little bit more comfortable about that. All right, let's go back to our developing decision tree. We understand what the probabilities mean, and now we have our 2 outcomes. What we're going to do is we're going to take that particular outcome, the $170,000, and we're going to multiply it times that 0.7. And that's where we get $119,000. We're going to do the same for our low end outcome with the 0.30, and we're going to get $24,000. Add the 2 together, and we get $143,000. So congratulations, you've just calculated your first expected value or expected profit. Pretty easy. Wasn't too hard, was it? Okay, now let's calculate that return on investment, ROI. You've probably heard this used a million times on the news, radio. What does this really mean? And why do we use ROI? Well, it's really all about calculating how much is in it for us. It's an easy way to look at 2 alternatives and compare, again, which one's going to get us the most money. Think of it in your own personal life. Would you rather have a savings account that paid you 2% or 14%? Obviously the 14%. And this is something, again, a mechanism, a tool for managers to figure out which one is going to have the best return. All right, so let's calculate this. It's very easy to do. In this case, we're going to take our profit over our investment. That's the formula. Again, don't worry too much about freaking out about formulas. This is a pretty easy one. We're going to take that profit, which was that expected value or expected profit of $143,000 over the $1 million cost, and divide it out, and we come out to 0.143, or convert that to a decimal by multiplying times 100, and you get 14.3% return on investment. Pretty good. Again, that's your expected return on investment on this particular project. That is a very nice return. You'll have some companies have certain requirements where any investment choice must meet certain minimum ROI. So this is a nice way for a manager to make sure that they are meeting a certain ROI required by the organization. All right, let's throw in a little bit more variation into our problem. And this is really neat. With this particular problem, we're doing a lot of things. Not only are we doing variance, standard deviation, but you're also getting some probability theory in here as well. So we're getting a lot of bang for the buck with this particular exercise. So hold with me on this one. Okay. All right, so you're all set. You're getting ready to buy this scanner. The ROI looks pretty good, but you learned some disturbing news that you've been talking to consultants and your other managers and the research that you've done, and it looks like that reimbursement for imaging procedures, how much you get paid to do those fancy scans, has a 25% probability of going down with the Affordable Care Act. So you're going to actually make less money on these scans, and we've estimated that it's going to be a 25% chance that reimbursements will go down. And actually, folks, this is real world. Imaging managers all across the country really are struggling with how this is going to affect them. There is a prediction that reimbursements will go down, but that's just a little side piece. So this is actually rooted in reality. All right, so how do we plug in this particular probability now into our decision tree that we've been creating? All right, so here's our old buddy, our decision tree that we've made. Again, the probability should look familiar to you. 70% chance that you're going to make $170,000, 30% chance that you'd make that 80 grand on the purchase of the scanner. Okay, but now we're going to add some more branches to our tree. Hang with me here. It's as long as you follow, it's very systematic, you'll be just fine. So each outcome now has a different environment that can happen. So if you think about it, as I said on the previous slide, that there was a 25% chance that reimbursements could come down. And through your research, you've calculated, if that happens, that your top end reimbursement now would be $150,000 for the year. So that's where you get that number. Now, if we know that it's 25% chance that reimbursements are going to go down because of the Affordable Care Act, then the flip side is 75% chance that nothing's going to happen and you're just going to be fine. And that's where you get the $170,000 there. Same thing for the bottom branch. Again, if reimbursements go down, there's a 25% chance of that happening. You've estimated through your number crunching that that would be $50,000 that you would have in profit for the year. And again, if nothing happens at all, which is a 75% chance that nothing will happen with the Affordable Care Act that will impact your reimbursements, that original number of 80 grand stays intact. Let me just make a couple comments here about some of these things. Where do I get these numbers? The 150, this 170, these are all, basically are provided to you. You've estimated, you've done your research on what reimbursements would be. So those are kind of numbers that are given to you through, I guess, the environment, if you will. So there's no way that you actually calculate those. And the percentages, going back to the very beginning, the 70% and 30%, and then now the estimated 25% chance that reimbursements will negatively impact the downward volume in reimbursements will negatively impact you. These, again, just kind of are provided. So that is where, I guess, really the danger of this analysis comes into place, and even in the real world, especially with the percentages. If you're off on these percentages and how you calculate them, your decisions can be fatally flawed. So know that if there's any kind of Achilles heel in an analysis like this, it would be more typically, how do you calculate a chance of something happening? And do you have enough data that's coming together to pull those chances, to give you a good estimate of what those chances are? Because that kind of drives everything. But in our case, we're going to say they're provided by, the environment in which we work, and we know these numbers to be pretty solid. So those are going to be our assumptions. Okay. So now we've made our decision tree out a little bit further. Again, we've structured it with the multiple alternatives for each of the two scenarios under the Affordable Care Act, the negative impact on reimbursements. Okay, so what do we do next? Well, what we want to do is take our two probabilities. We have the probability of 70% times the probability, we'll start at the top, doesn't make any difference where we start, but let's just work our way down, times 0.25. So you take the 70 times 0.25, multiply those first. It's kind of an order of operations. So multiply your two probabilities together, and then you're going to multiply that times the 150,000. Okay, you do that math, and you come out with $26,250. You're going to write that down. And now we're going to go through that for the rest of the tree and come up with our numbers. But we're not quite done yet. We got some more math to do. Okay, so what we want to do now is take all of those numbers that we've just calculated and add them all together. And now we get a new expected value or expected profit under this Affordable Care Act scenario of $137,250. Not too bad, considering it sounded like doom and gloom. Our expected value is pretty much, not impacted that greatly. But here's some other interesting things to do. When you took those two probabilities and multiplied them together, that's this pink column right here. So the 0.7 times the 0.25 equals this new probability of 0.175 and then so on all the way down. Here's kind of the mind-blowing thing. If you take those probabilities and add them all together, they should always equal 1. For any series of outcomes, they should always equal 1. So if you look at your first decision tree, those probabilities again equal 1. If you look at each one of the branches, they always equal 1. And in our case, for all 4, because now we're looking at 4 possible decisions, they always equal 1. So kind of an interesting thing about probabilities, and something you can always do to check yourself to make sure that you've done the math correctly. It's kind of a cross check. So there's that. All right, but now we're going to move on. Now that we've calculated our new expected value or expected profit, let's move on to some interesting areas. But before doing that, let's real quickly, let's do the return on investment now on our new scenario with the Affordable Care Act in there. Again, your profit over the cost of the investment. We now have that new value of $137,250, and now we've got an ROI of 13.7%. Again, not bad, considering it looked like we were bringing a lot more risk to the situation. Overall, it still looks pretty decent, but that's not the full picture yet. We want to look at variance and standard deviation. This will help us get a deeper picture on really the risk of this particular endeavor. And then also, there's a lot of power in comparing standard deviations between two alternatives. Just as comparing ROI is important in two alternatives, looking at the deviation is very important as well. All right, so how do we do standard deviation? I know you're running for the hills right now. You've heard about how horrible this is. With this particular example, we're doing it the way that the textbook does. There are more pure statistic ways to do this with formulas that are kind of intimidating. We're not going to worry about formulas in general. It's going to be more of a mechanics, how these things work. So you could set up decision trees, and then you could also find standard deviation and not really worry about the formulas. So know that. All right, so let's bring back our old friend, that decision tree from the previous page. I've cut off the first part of it just to save space. So here we go. Again, we got all of our final probabilities, that pink column. Let's also bring back our friend, that expected value or expected profit, because we'll need that 137,250. And let's start the process to calculate. First, we'll calculate variance, which in of itself doesn't have too much value, especially the way that the textbook presents it. The more power is with the standard deviation. But we have to get variance first to calculate standard deviation. So here we go. Get your calculators ready. The first thing that we want to do is take that expected outcome, or I should say that 150,000. Remember, that was that low end number that you came up with, that through your research as a manager, you realized, oh boy, if Affordable Care Act comes through, I'm only going to make 150,000 if it's negative. If the impact is anticipated to be negative, I'm only going to make 150,000. You calculated that number before coming into this problem. You're going to take that number and you're going to subtract your new expected value. And again, if we were talking in statistics, it would be mean, but we're not going to worry about that. So you're going to subtract that new expected value. You're going to come up with a number. And don't worry about negatives or positives. You'll get a negative in many cases. It all disappears because once you square root it, it always becomes positive. Or once you square it, I should say, it always becomes positive. So also be aware of order of operations. I'm not here to make you math majors, but anything in parentheses kind of done first and by itself. So all right, in this case, we're going to come out with a positive on this one, but you take the 150,000 minus the 137,250 and square it. Then multiply that times that probability, that kind of that new probability of the 0.175, and you get this horrendously long number. Just write it down. Maybe do your calculations twice, but write it down. And that is part of the variance. And you want to do that for all 4 of these. So you get these, again, these tremendously long numbers. You will want to then add them all up. And as I said, those are all part of variance. Once you get them all added together, congratulations, you have just calculated your first variance. The hard part here, and the one that I always had to double check myself on, is not making a mistake when you run through all the calculations. Again, in some cases, you'll get a negative number when you do your you do your first dollar amount, then minus the expected value, but then you square root it, it becomes positive, and it's a huge number. And then you multiply that times that probability number, that kind of what we'll call a combined probability number, and that brings it down to a little bit more reasonable size. But again, it's still a very, very large number. So you got to be careful kind of going through the mechanics. If you are comfortable with Excel, by all means use it. There's a lot of shortcuts on Excel to calculate standard deviation. In this case, it's not too bad with a calculator. You can run through it in about 5 minutes or so. So again, you get all these numbers. You've added them together, and congratulations, you've just calculated variance. Super. Now, as I said, this particular textbook doesn't really focus on the value of variance. What it focuses on is what's produced out of variance, which is standard deviation. And to calculate standard deviation, you will square root that big number, and it comes down to, thankfully, a much more reasonable number. So the standard deviation under this particular scenario, with the high and low profit that you have on there, chances of those profits, and then also the additional probability or chance of Affordable Care Act impacting this, you end up with a standard deviation of $43,588.27. Okay, so congratulations. You have done a decision tree. You've done standard deviation. You've talked a little bit about probability. Again, we've covered a lot of things throughout this problem. So what does this all mean? What does standard deviation mean, and why do we even care about it? Well, standard deviation is really a measurement of risk. Now, we can get into a lot of statistic stuff with this, but it really tells you that how much a result is expected to move away from that average or that mean. And I guess for most decisions that you'd want to make, you would want to know that, okay, you know that there's going to be some possible outcome one way or the other when you make a decision. But you want it to be, those two outcomes to be relatively narrow in their numbers or in their outcome. So you know that it's not going to hurt you that much. If you were to make an investment in this scanner, and if you made $170,000 or $80,000, that may be acceptable to you. If it was you make $170,000 or zero, again, that could be a wide spread, and that would also be reflected in a much larger standard deviation. So you'd rather, when you're looking at two comparable options that have relatively the same return on investment, you'd want that standard deviation to be as narrow as possible. Now, the thing that happens in the market, usually, not always, but usually, is that for any investment alternative, and that's what we're looking at here. We're looking at an investment. You're purchasing a scanner. That the more risk that you assume through risk, maybe defined as standard deviation, you would receive a higher return on investment. So you'd be rewarded for that variability that you're willing to accept in these outcomes through, again, a higher return. And naturally, the market usually kind of gets these things in line. So something with the ROI of, let's say, 4% may have a very, very narrow standard deviation because it's pretty much a sure thing. And something with that's not so much a sure thing, well, you want paid a little bit more for that. So your return on investment you would expect to be a little more. Again, why is this important? It's a tool for managers to use. And we're talking about economics, which in this case has to deal with limited resources and picking the resources in the most efficient manner for you. So again, standard deviation can be one tool that you have in your toolbox to help make decisions on limited resources. So excellent. You've gone through a lot in this particular presentation. We have talked about decision trees. We have talked about standard deviation, expected values or expected profit. The one thing that we haven't mentioned is sensitivity analysis, which I promised that we would talk about, and that's very easy. All sensitivity analysis does is, as the manager, calculating these numbers, is you throw in what ifs in there. You kind of go, okay, what if the probability on the Affordable Care Act having a negative impact on reimbursements was a 30% chance rather than 25? What would that do? And then you run the numbers. Or you run the numbers, let's say, well, what if we got the profit wrong? What if the maximum profit was $200,000 and the minimum profit under this whole scenario was $0? You could run those numbers and then compare them with your other scenarios. So that's all that sensitivity analysis really is. So again, congratulations. There's a lot of information in here, but I want to give you kind of a general feel of how this works. If you are asked to do any of the standard deviation, it will be very simple. Again, don't have to worry about formulas, more of just do a kind of a constructed process. The formulas can be kind of intimidating for folks. We're not going to really emphasize too much on the formulas. But hopefully with this approach, you can be confident in at least calculating variance, standard deviation, ROI, and constructing a basic decision tree. So again, congratulations, and thank you for watching.